In this video, I'll show you how to use GeoGebra to answer probability questions using the normal distribution. We'll focus on the left tail probability. So first, let's go to the website geogebra.org/classic#probability. We're going to be on the distribution tab, and you want to make sure that the distribution is normal. We'll figure out the other boxes later. I've set up some examples. The first one is, according to a study, the average number of faces an adult can remember, in other words, recall the face and remember the name, is 150. Let's assume a population standard deviation of 30 faces and a normal distribution, a normal model. First question, what percent of adults can remember fewer than 125 faces? So the key here is that we want to look at fewer than 125 faces. That's going to be our cutoff, and anything less than that is fine. And we need to know the mean and standard deviation of this distribution. So the mean is 150 faces, the standard deviation is 30 faces. So we'll go to GeoGebra and change the shape of our normal distribution. We're going to put mu, the mean, to be 150. And the standard deviation back here was 30. So type in 30, and you can type enter just to lock that in. It'll normally change for you though. So the question says, we know that this is the shape of the distribution. You can see the number of faces along the bottom axis. We're curious about the probability of adults knowing less than 125 faces. So we're going to use a left tail probability. So I'm going to click the button for left-sided probability, and our picture will change. And then we need to give the cutoff that was from the problem, and that was 125. So I'm going to change the box x less than or equal to 125, push enter, and we get our answer. You can also grab the little triangle that's the cutoff of the purple shaded area and the other region and move that around. You can get pretty close to 125, but we want exactly 125, so edit that as needed. So our answer is 0.2023. So about 20% of adults can remember 125 faces or fewer. So one thing to note is you don't have to get hung up on, is it less than 125? Is it exactly 125? Is it 124.99999? We just use the number 125 as our cutoff because the probability of exactly 125 faces, in other words, 125.00000 out to an infinite number of zeros, that is one number out of infinity. So the chances of actually remembering 125 exactly is 0. So it doesn't matter if you say 124.9999999 or exactly 125. That one extra number out of this entire continuum is going to add no appreciable extra probability. So we can put in 125. Don't overthink it. So let's go back to the example that I'd had worked out. I drew the normal distribution, I put the mean, and I put the cutoff, and here's the standard deviation of 30. If you were to work by hand, you would come up with a z-score first. You'd take x minus mu and divide by sigma. So we'd take 125 minus the mean of 50 divided by the standard deviation of 30. So do that math and we get a z-score of negative 0.83. So we use 2 decimal places because if you're going to work from a table in the book, it only goes out to 2 decimal places. So you'd round out to 2. So you'd go into the table of the book and you'd say, okay, well, I have a z-value of negative 0.83. So you'd look in the row that says negative 0.8, you'd look in the column that says 0.03 because there's the 0.8 in the 10th place. The 0.03 is the 100th place. You look where the row and the column meet, and you're going to find the 4-digit decimal place of 0.2033. So notice that that is a tiny bit different than our answer of 20.23 that I got from GeoGebra, and that's simply because of rounding error. We were able to use the exact z-value, or actually we didn't even compute a z-value. We looked at 125 exactly. We didn't need to do any rounding in GeoGebra, so we got a slightly different answer than we did from the table, but they're not too terribly different. You have the right idea. So if you do have questions, you can always talk to your instructor about how correct your answer is. But normally, both of those answers would be considered correct. So there you go, our first example of computing the probability to the left of a cutoff using the normal distribution.